Okay, this next part we're just going to start with some theorems and properties that are given in your text. So if a function f is differentiable at a point A, then f is continuous at that point. Okay. Also, the derivative of a linear function, if f of x equals y equals mx plus b, this is your slope-intercept pretty much, then the derivative is equal to the slope. Also, the derivative of a constant function, if f of x is equal to b, so where b is just some number, some constant, then f prime of x is equal to 0. And we also have a power rule, which we'll write next. Okay, so our power rule, let n be an integer. Okay, if your function is x to the nth power, then the derivative is defined by n x to the n minus 1 power, provided x is not equal to 0 when n is less than or equal to 0. Let's see an example of that. So if my function, here's our first one. If I give you the function f of x is equal to x squared, then by the formula, and you'll be able to calculate these without having to write it all out, but for this first few, it's going to be n, which is 2, so 2 to the x, and then I have 2 minus 1, which is just going to be 2 to the x power. 2 times x. Excuse me. Okay, so basically what you do here is you just multiply this time in the front, 2, and then subtract 1 up here. So let's see it again. Let's see the next one. X cubed. So f prime of x, without having to write it completely out up here, we're just going to do it. So you multiply by 3, so you're just going to get 3x, and then subtract 1 from the exponent. So what's it become? 3x squared. Good. So it's actually easier if you don't have to write out the whole step. So again, if my original function that is given to me is an x to the 4th, then f prime of x is simply going to be 4x to the 3, subtract 1, so on and so forth. Let's see if we have 1 over x. Okay, now what we do here is, first of all, I want to rewrite this because it's not necessarily in this particular format, right? This is fraction format, but how can I rewrite this? How can I rewrite that? X to the negative 1 power, good. So now whenever I calculate the derivative, that's just going to be negative 1. So I'll pull this negative 1 out front. So negative 1 x to the negative 1 minus 1, which would be what? Negative 2 power. Or if I simplified that back to the original format in fraction form, that's just going to be negative 1 over x squared. Okay, these two are equivalent. Okay, let's do one more just so you can see this in a couple of different takes. So if I have the cubed root of x squared. Now the trick with this is to fit our power rule up here, we need it to be in this format. So how can I rewrite this? That would be x to the what power? To the 2/3 power. Good. Okay, now if I take the derivative of x to the 2/3, I'm going to have f prime of x. That's just going to give me 2/3 x, and then I do 2/3 minus 1. So off to the side, 2/3 minus 1 is 2/3 minus 3 over 3, which would be negative 1/3 power. Right? Okay, let me take that scratch work off. Which would just be 2/3, and I can move x to the 1/3 down to the bottom, or it could be written as 2/3 with the cube root. Make sure you can see that. That's a cube root of x right there. Okay, that's just algebraically simplified. These two are equivalent statements. Okay, to extend that a bit, we also have if a function has c some number out front, x to the n, then the derivative is just c times n, multiply that, x to the n minus 1. So let's see an example. If we're given, excuse me, I have a cold, so 3x squared minus 12x plus 8. So if I took the derivative of this particular function term for term, I have that 3 that's just already there. So if I covered up the 3, I would say 2 x to the 1, right? So I have that 3 that's already there. So I say 2 times 3 is 6. X to the 2 minus 1 is just 1. Here, I have minus 12 because there's a known 1 here. So 1 times 12 is 12 with no remainder. Not no remainder, I will have x to the 1 minus 1, which would be 0. Anything to the 0 power is just 1, right? So plus the derivative of a constant is 0. So f prime of x would be 6x minus 12. Next, we're going to work on notation of derivatives, and so these are considered higher order, anything over first order. This is a first order derivative, second, third. These are just higher order. So, and we're just specifically talking about notation. So if I have f prime of x, this is what we've been working with. That's our first derivative. To do the second derivative of that, you have two little prime marks there. Second derivative. Third derivative notation would be that. So if you're given this notation, it's asking you to find the third derivative of the original function that's given. Okay? Sometimes you will see it as d dx of f of x. So that's the derivative of the function. D squared x of f of x. D cubed x of f of x. So that's like asking for the first derivative, second derivative, third derivative. Derivative of x with respect to y. The second derivative of x. Whoops, of x. The third derivative of x. With respect to y, the only difference in notation here is, remember, f of x and y are interchangeable. Okay, there. So sometimes we see it as that. Also, you will see y prime. Remember, because that's the same idea as the f of x notation and y equal are interchangeable. So that's just saying y double prime, y triple prime. Sometimes you will see dy dx, change in y over change in x, d squared y, dx squared. That might be hard to see. And then this one's d cubed y, dx cubed. And sometimes you'll see it so that you can see it's a change. Occasionally you'll also see dx, so the derivative of your function. Sometimes you'll see that. Okay, and then you would just have squared, squared, cubed, cubed, like the previous one. So at any given time, the notation presented to you may be any of these above. So they're all interchangeable and they all tell you to calculate derivative. If we consider higher order derivatives, this would just be all the different notations you might see in asking for your second derivative. Let me make sure that's for your second derivative, and in the third column for your third derivative.